Structural Geology and Rock Mechanics, Module 3 for Civil Engineering Department. Course code is 18CV36. Course name is Engineering Geology, Session 3. RQD, Rock Quality Designation. The rock quality designation was developed by DEER to provide a quantitative estimate of rock mass quality from drill core. In drilling, there are three types of drilling. One is DTS, down to the hole. Then second one RC, reverse circulation drilling. Then third one is core drilling. For RQD test, this core drilling is considering while they are drilling the core drilling, while they are in core drilling, there is a barrel, that is 3 meter length of barrel. One run, if they are collecting 2 meter or 1 meter or 3 meter core, in that core there will be some fractured core and pieces of core. So we are measuring each pieces of core in a one run. Above the 10 centimeter pieces are considering for the RQD calculations. We are taking average from those length of core and multiply by 100, so you will get the percentage of RQD. So RQD is defined as the percentage of intact core pieces longer than 100 mm, 4 inches in the total length of core. The core should be at least NW size, that 54.7 mm or 2.15 inches in diameter, and should be drilled with a double tube core barrel. The procedures is measurement of the length of core pieces and the calculation of RQD. RQD is intended to represent the rock mass quality in situ. So rock structure rating, RSR. Rock structure rating is a quantitative method for describing quality of a rock mass. There are considered two general categories: geotechnical parameters, in that rock type, joint pattern, joint orientations, type of discontinuities, major faults, shear and folds, rock material properties and feathering in the particular area. Second one, construction parameters: size of tunnel, direction of drive, method of excavation. Geological site characterization, dam foundation and rock foundation treatment for dams. For selection of dam sites, we are observing first narrow river valleys. The cost of dam construction will be less in narrow river valley. Dam sites bedrock at shallow depth. In dam site, bedrock will be shallow depth. The safety and stability of a dam site has to be physically very strong and very stable. Dam sites competent rocks for safe foundation. If igneous rock occurs at the selected dam site, they will offer a safe basis. Dam site suitability of igneous rocks. The occurrence of massive plutonic or hypobasal igneous rocks is the most desirable at the dam site due to the strong and durable interlocking texture, hard silicate mineral composition, occurrence of negligible porosity and permeability, and absence of weak planes in igneous rocks. All plutonic rocks like granites, syenites, diorites and gabbros are very competent and desirable rocks. Volcanic rocks, which are vesicular or amygdaloidal, are not equally desirable. Dam site suitability of sediment rocks. Sediment rocks, the bedding and its orientation, thickness of beds, nature of compaction and cementation are main features. Grain size, leaching of soluble matter, porosity and permeability associated geological structures and composition of constituents also major attention for dam sites. Sandstone with siliceous cements are generally reliable. Limestone, which are carbonate type sedimentary rocks, although it's massive, thoroughly compact and fine textured limestone, form quite sound foundations. The Salal Dam in Jammu is located in a limestone region and rock is fine grained dolomitic limestones. Shales are the most undesirable sediment rock as far as their suitability for dam sites is concerned. Dam site suitability of metamorphic rocks. Gneisses are mostly competent like granite unless its major foliations and are richly accompanied by mica like minerals. Quartzites are very hard and highly resistant to weathering. Marbles like quartzite are compact, bear a granulose structures, are not porous nor permeable and practically strong too. But its chemical composition and minerals are unsuitable at dam site. Marbles also is containing calcium carbonate, that's why it is unsuitable at dam sites. Slates bear a typical slaty cleavage, hence this rock is soft and weak and undesirable at the dam sites. Dam sites effects of associated geological structures. For the stability of a dam, the occurrence of favorable geological structures is a very important requirement. Dam sites cases of undisturbed, that is horizontal strata. This geological situation is good at the dam site because the load of the dam acts perpendicular to the bedding planes. So dam sites beds with steep upstream dip, no uplift on the dam site and no leakage of water from the reservoir due to steep dip the bedding planes. So sites beds with steep downstream dip, the resultant force and bedding planes are nearly parallel, which means that the beds will be even less competent. So dam sites beds which are folded. Folding of beds which occurs on a relatively larger scale. The folding is in larger scale, that sites will be suitable, but in local scale, so dam sites will be unsuitable. Dam sites beds which are faulted. Occurrence of faulting irrespective of its attitude, strike and dip right at the dam site is most undesirable. Dam site beds which have joints. Joints are the most common and are found to occur in all kinds of rocks, all type of rocks, but joints in depth wise it will be disappearing. In surface joints will be more, whether we are considering in depth wise joints will be nil. So such type of area is suitable for dam sites. Thank you.